Excellent. Here we are talking about homeostasis, which is the maintenance of a constant environment in the body. Homeostasis has different mechanisms. We need these mechanisms because cells work best if they have the correct temperature, glucose concentration, and water levels. So what we want to do today is we want to talk about these different mechanisms that keep our cells in a constant environment. So first let's talk about controlling body temperature. You have to understand that all mammals do indeed maintain a constant body temperature. You are a mammal. We used to call ourselves warm-blooded, but that doesn't make any sense because even cold-blooded animals have warm blood. So we are endotherms, they are ectotherms, and we generate our own body heat. So what does this mean? This means that we're 37 degrees Celsius in our body. Doesn't matter what the outside temperature is. It could be -8, could be 47. Our temperature is still going to be 37 degrees Celsius. So how do we control it? One of those ways that we control it has to do completely with this concept of surface area. So look at the surface area of an organism, compare it to their volume. Okay, here you go. Here's an organism. It's a little cube organism. He's 1 by 1 by 1. So 1 times 1 times 1 is 1. And so his volume is 1. And his surface area is, yes, 6. The other one, we have another organism over here. This is a rectangle organism. And it is 2 by 1 by 1. So its volume is 2. Its surface area, if you count them all, you might go, hey, that's 12, but it's not because there's 2 of them that are touching, so those both get subtracted, so it's 10. So it's a 2 to 10, which is a 1 to 5. That's right. So we have the volume to surface area ratio on this small one is 1 to 6, and the volume to surface area ratio on the larger one is 1 to 5. That means that for every 1 unit of heat made, heat is lost out of 6 sides on the little organism, and for every 1 unit of heat made, heat is only lost out of 5 sides on the larger organism. Therefore, the bigger the volume to surface area ratio is, the faster heat will be lost. That means if you're just a little guy with more surface area compared to that volume, you're losing heat faster. All right, penguins are an excellent example of body volume and surface area. So if a penguin is all by itself, then all of that surface is exposed and it can lose a lot of heat. So what they do is they huddle together, and all of those that are on the inside don't have any surface area that's being exposed, so they're keeping all of their heat. Those little guys on the outside, of course, are getting a lot of that problem where they're losing a lot of heat. There's a lot of horrible winds and cold temperatures that are certainly getting on them. But what's very cool about penguins is they take turns. So these little guys that are on the outside are not going to be on the outside all the time. They are simply taking their shift right now, and then they will swap places. Very cool, those penguins. All right, let's talk about some cooling mechanisms. Of course, they're sweating. We all know sweating. So when your body's hot, the sweat glands are stimulated to release sweat. We're all like, yeah, I knew that. The liquid sweat turns into a gas. It evaporates. To do this, it needs heat. We know that if we want to turn from a liquid to a gas, you're going to need some energy. So that state change requires the heat. Now, where's it going to get the heat? Of course, it's coming from your skin because you are feeling very hot. So as your skin loses the heat, it cools down. So here's a little graphic for you. We can see the skin there. We see our body temperature. So our temperature went up. As a result of it going up, sweat bubbles to the surface of the skin. The heat is going into that sweat that's on the surface of your skin. It evaporates, cools you down. You feel much better. Now that it's cooled down because there's no more heat. There it is. And since there's no more heat, there's no need to sweat. And that goes away as well. This is a negative feedback system. Another way of cooling, vasodilation. Your body carries most of the heat energy around in your body in the blood. There are capillaries underneath your skin that can be filled with blood if you get too hot. This brings the blood closer to the surface of the skin so more heat can get lost. And this is why you look red when you are hot. So you've got all these veins and all these tiny little capillaries that are coming off way up into your skin. They're coming to the surface of your skin. They're filling up with blood and the heat comes off you. And yeah, you can kind of feel the radiation coming off you. This is how that looks. So here we've got our body temperature. Hello. We've got our skin. We've got our vein, and we've got our lovely capillary. Let's open that sucker up. Oh, I'm so hot. Temperature went up. Okay, temperature rose. It's dilated. Awesome. All this blood is going up in there. Heat's getting off. Yes, heat's coming off. We're feeling so much better. And then, of course, this is then going to go down. Your temperature goes down. The whole vasodilation thing doesn't need to happen anymore. Bam. Negative feedback. Okay. Let's look at some warming mechanisms. Vasoconstriction, absolutely. It is the opposite of vasodilation. The capillaries that are underneath your skin are now going to get shut off. Okay, they're constricted. This takes the blood away from the surface of the skin so less heat can be lost, and here's how that looks. So here's our temperature up here at normal, at homeostasis. Ooh, it goes down. We're losing too much heat. So let's cut it off right down here. Now we're not having this blood diverted up to the surface of the skin, and now we're not going to lose heat anymore. Ta-da! That is also negative feedback, because as soon as we stop losing that heat, it's going to go back up. Let's look at some more warming. Piloerection. This is when your hairs on your skin stand up. You guys know that as goosebumps. So the hairs trap a layer of air next to the skin, which is then warmed up by your body heat. The air becomes your insulating layer. So here you are. There's your body temperature on the side. Here's your hair on the skin. Your temperature drops and up comes your hairs, causing this insulating layer. And so those hairs standing on end in the chicken skin is not permanent. So once your body warms up again, the chicken bumps will go away, your hair will drop down. Let's control some glucose levels. Your cells also need an exact level of glucose in the blood. Your cells also need an exact level of glucose in the blood. Excess glucose gets turned into glycogen in the liver. This is regulated by two hormones. That is insulin and glucagon. They're both made in the pancreas. Okay, you got that? So excess glucose gets turned into glycogen in the liver, and insulin and glucagon are made in the pancreas, and those are two hormones that help to regulate this process. Let's look at it. So here we have a liver. It's got some glycogen in it, and we've got our vein here, and it's got some glucose in it. If there's too much glucose in the blood, then insulin needs to convert some of it to glycogen. So there's some that pop away. Insulin takes that over to the liver, and there's your bigger glycogen, right? Okay, if there's not enough glucose in the blood, then glucagon is going to convert some glycogen into glucose. So let's watch this happen. They're gone. Where did they go? They went into the blood with the help of our glucagon. Now we've got more glucose in the blood. Ta-da! That's how it works, right? Also a negative feedback system. Let's look at diabetes though. Some people don't produce enough insulin. Some people can't even produce any insulin at all. Their pancreas is like shot or something like that. Doesn't work. Never worked. It depends. When they eat food, the glucose levels in their blood cannot be reduced. It just skyrockets. And that is what diabetes is. So diabetics sometimes have to inject themselves with insulin so that they can level out their glucose levels. So they also have to be very careful with their diet. If they're not careful with their diet and they take in too much glucose, then their bodies are going to spill that glucose directly into the urine, and that's because their kidneys can't absorb enough of it. And so it spills into the urine, and along with it, all this water follows. That's an osmosis thing, and that leads to this dehydration. So now that they're dehydrated, and on top of that, they're not getting any energy because they can't use the glucose because they peed it out too soon. And so now they're relying on fats and proteins for their energy. And from there, we'll talk about in a sec, bad news. So they have to be very careful with their diet. Here you go. Here's glucose concentration on the y-axis. You've got time on the x-axis. This is a normal person. Okay, here I'll just kind of move this over so you can see. Hello, I'm a normal person. All right, so I eat my meal, and down it goes, right? The glucose levels naturally rise after a meal. This makes a lot of sense, but because we have that insulin, we can take any excess glucose that's in our bloodstream and store it in our liver as glycogen, right? It's all good. Insulin's produced, glucose levels fall to normal again. That's one of those negative feedback things. Here's a diabetic. Yep, just up and up and up. Glucose level rise after a meal and they stay up after that meal. So here you are. The glucose in the blood increases. There is no go for insulin. Can't convert it over to glycogen. So it's just going to be dangerously high inside of your bloodstream. Ta-da, that is what it looks like. What do we mean when we say dangerously high? I had alluded to this before. So now, instead of taking in the glucose into our cells and using glucose, which is our cell's preferred form of energy, we're going to have to rely on fats and proteins. So you're relying on fats, that's going to make your blood very acidic. You rely on proteins, you're going to start dropping your body weight. Some people are like, yes, Atkins diet. No, ketosis is not a good thing. Due to that loss in protein, you're going to lead to a decrease in your ability to fight infection. And so along with this acidic blood and your decreased ability to fight infection, you can slip into a coma and you can die if it's not corrected. So that's what we mean when we say dangerous levels. So that is diabetes. Let's control some water levels. We were talking about that just a second ago with the reference to having to get rid of that glucose in the urine, and then all this water comes out also in the urine. Okay, so blood comes to the kidneys through the renal artery, and kidneys clean the blood of waste products such as urea. You can't have urea in your body. That comes from unneeded protein metabolism that's been conducted by the liver. The kidneys are going to control how much water is kept in the body. So waste products plus water equals your urine. Remember, we were dumping all of that glucose out when we were diabetic, and a lot of water had to go with it, and that's one of the things that the kidneys are responsible for. Can't get rid of those waste products without getting rid of water. And also your body needs to know, oh, I need this water, and so it will also retain it. We'll talk about that. Okay, so here's the filtration process. Blood enters the tubule area in a capillary. The capillary forms a small knot. It's a beautiful knot, isn't it? Near the kidney tubule. The blood is filtered so all the smaller particles go into the tubule. Ta-da-da. Into the tubule they go. The capillary then carries on to run next to the tubule. And there it is. There's the capillary running next to the tubule. The kidney tubule now contains lots of blood components, including glucose. There's your glucose, ions, water, and urea. So now we're going to reabsorb the sugar. Remember, if you're a diabetic, this is not happening. It's not happening fast enough, or it's not happening at all. So the body needs to have sugar in the blood for cells to use in respiration. Remember, that is how your body makes the ATP, which is what your cells run on. Okay, so you've got to be able to have this sugar. If you're a diabetic, you're not going to get the sugar. You're going to end up using fats. You're going to end up using proteins. Remember that. Okay, so hopefully all the sugar is reabsorbed back into the capillary. That's the ideal. Water and ions are the next to be absorbed. If they are needed there or they're not particularly needed, then they'll stay there in the tubule, but it depends on how much water is actually needed by the body. So not all of them are going over. So let's look at reabsorbing the water. Okay, if you have too little water in your blood, you'll produce very concentrated urine. So that's very little water is in it. So thinking about your blood needs water because it's got to flow like a river, right? It's got to flow. So if you barely have enough water in your bloodstream as it is, it's not going to get rid of it. And that's what urine is. It's a waste product. So if it's very dark, that means that you needed all that water. If it is dilute, it's a very light yellow color, that means you have too much water in your blood, and it's easy. Let's get rid of this. Okay, So that's how your body decides whether to get rid of the water or keep the water. So now it's time to excrete the waste. Everything that is left in the kidney tube